Hello.
Oh, hello আপু।
Wait,
আপনি
coach.
স্ক্রিনটা শেয়ার করে রাখতে পারেন।
Yes, Raju is here, I believe. Hi, Raju.
I think we need to grant him presenter mode. Yeah, yeah.
It is.
Hi
Hey, hello.
Raju.
Hi.
Hi, how are you doing?
Yeah, I'm all good. How are you?
Yeah, I'm great. We never met before, right? So I'm Sharima. I'm also a co-organizer with Naz and Tree.
Yeah,
Yeah,
nice to
nice to
meet
meet
you.
you. Yeah, same here.
Nice to see you again, Raju. Thank you for joining us today.
Yeah, no problem.
One thing I wanted to mention before we start, Raju, is that we have changed the cloud credit rules, like GDG changed it, and we have to pre-register for virtual events. So if the participant haven't applied, like registered with a Gmail account, then we have to add them. So if you can mention it in your workshop that if they haven't registered with the Gmail account, they can drop their email and we will add them.
Okay, sounds good. Yeah, I
Thank
will
you.
include that in my slide as well. Just give me 1 second.
I think people have started joining. So
Yeah.
But
Yeah,
the
we can go
link
to the
is, yeah,
front.
the credit link is not changed, right? It's just the same one.
This is I think the QR code is the link. We can also like share it in the chat.
Let me check because I have included that in the slide as well. Let me check if it's the same. Okay, it's 1, 2, 3. Yeah, it's the same one. Okay, cool.
Sharma, you can go to the welcome page maybe if you want. So. Also, Sharima, another thing I wanted to show you is for the speakers. Like if you go to the participants and if you click on the speaker's name, there's like three dot options.
Mhm.
So if you go there, when the speaker, like for now, Raju's presenter mode is on. When another
Mhm.
speaker comes in, you have to turn on their presenter mode so that
Present.
they can present. Yeah.
Yeah, yeah, makes sense. Makes sense. Mm, okay. So this is the first slide I can see. Naz, for now.
I think there is a welcome slide.
I don't think so. Yeah,
Pre,
this is the first slide I have here.
Let
pre.
me check. There was a welcome slide.
How did it?
Yeah, I got the previous version, so maybe I can share it.
Oh, yeah, there's the welcome slide.
Yeah, restore this version. Yeah,
Um,
yeah,
Somehow
it should be good now. Mm, yeah.
Raju, is everything is okay with you? Your sound, video, and all the things you need?
Yeah, everything is good. So I think
Cool.
I can present also with the presenter mode, right?
Hmm.
Yeah, you can check. Alrighty, so I think we're gonna wait till 5 and then we can start.
We will wait for another couple of minutes and then maybe we can start.
What is the local timing there? Is it 5 p.m.?
Yeah, in Saskatoon, it's 5 p.m.
Okay.
What about you?
It's 7.
Oh, 7 p.m.? Okay,
Yeah.
that's great. Hi, everyone. Thanks for joining today's event. We will be waiting for another minute and then maybe we can start. Thanks for waiting.
I can also see Michelle has joined us. She's the other speaker that we have. So hi.
Okay. Hi, Michelle.
I think we can start now.
Yeah, we can start now. Michelle, you can access your camera and audio now? Okay, that's great.
Oh, thank you. Thank you. Hi, everyone.
Nice to have you.
Yes, thank you.
So, officially, hi everyone. Thank you for joining today's GDG Saskatoon Build with AI event. I'm Sharima, one of the organizers for GDG Saskatoon. With me, I have Pri and Naz. So currently, I'm working as an applications engineer at Siemens EDS Saskatoon. So I will request Pri and Naz to say hi to all of you and give a brief intro.
Hello, I am Naz. I'm a software engineer and I started GD Saskatoon around 2 years ago. And yeah, thank you so much for joining us.
Hey all, I'm Pri. I'm also a software engineer. I'm the co-organizer with Naz and Shahrima at GDG Saskatoon. Nice to meet you all. Thank you.
Okay, so without doing further ado, I think we should kick off our first, introduce our first speaker and get into our first talk. So here we go. We do have Raju Dawadi with us today. He's a Google developer expert in cloud platform, and he's a technology professional specializing in cloud computing, artificial intelligence, and multi-agent architectures, with a strong focus on open source tools and modern AI agents. And Raju is professional, like he is very passionate to bridging the gap between the experimental AI and scalable and production ready system. So we are very glad to have you, Raju, here today. Thanks for joining us and giving us your time. So the floor is yours. I will stop sharing and let you share your screen. Okay.
Yeah, sure.
Yeah.
Thank you. Thank you for organizing and thank you for inviting as well. Okay, there it is. Okay, just give me 1 second. So let me share my entire screen. Okay, so is the screen share good?
You are not in the presenter mode. I think I believe you can do the like slide show mode.
Okay, so the
Yes.
reason is I will be
Yes.
like switching tabs a lot. So
Okay. Okay. Okay.
Oh.
That makes sense. Yeah.
Okay, thank you. Thank you all again for joining and for organizing as well. So this is me. You can connect on LinkedIn or anywhere. So there are lots of things to do. So this is basically intended to be a workshop rather than just session. So throughout the whole session, you can do on your own parallelly. Maybe just share this screen share on your next monitor and start doing the lab as well. So this is the most important thing. So I've compiled everything starting from demo to the credit link to a lab and all of the resources, including this presentation link also in this link. And let me paste it here. Okay. So this link has all of the details, including the everything, seeing every single thing. So this is the lab we will be doing. So we'll be following each of the steps, and also you could also start claiming the GCP credit as well. Okay, so first thing, so I'll be doing lots of back and forth switching of the tab, maybe window, like everything. So first of all, so this will be our journey. So we'll be starting with a basic Python app. So no need to worry about. So the first thing, or the only one thing we need to be aware of is we just need to understand Python code at least. So we'll start with a basic Python app, nothing fancy, just a simple app. And then we'll be inserting some brain over the app. That means like maybe some AI models, right? And then we'll be making it more of like dynamic, giving it some persona, giving it some intelligence, and then making it a bit more fancier as well, right? So let's start. So first thing, so first step of our journey is the basic app, right? So if you go into the lab, so this will be the lab homepage, right? So we'll be starting from the first one, right? So for that, we'll need the GCP credit. So let's see how to redeem the GCP credit, because this might be a bit trickier. Let me check. Okay. So this has, I think, like $5 of the credit, which is valid for 180 days. So no need to worry about. And with this link, so we don't have to enter the credit card or any of the details. So this is like super fancy. Okay, let me redeem, just enter the name and then accept and continue. Okay, credit applied. This is the usual one, so I just leave it as Canada. Okay, let's give it a few minutes. And this will be enough for our lab, more than enough for our lab, the $5 of the credit. And this is our billing account now, the Google Cloud Platform trial billing account. So this is the default one. So if you want to renew it, maybe rename it, so feel free to. I'll just make it more simpler as well. Okay, let me refresh. Okay, so there it is. So the first thing, what we will be doing is creating a new project, because we need to have a GCP project for doing everything. So a new project, and the billing account should be the billing account we just created, the Google Cloud Platform trial billing account. And let's give it like GDG AI April 16. So this will be our project name, and this needs to be unique. So if I'm creating it, then you might not be able to create the same project name. Okay, the billing account we just created, and then create. So now we need to select the project. Okay, so the first step is done. So what we did is we created a billing account, we created a project, and tied the project with our billing account, right? So back to our lab. Okay, so there it is. So the first step, so all of these steps will do the same one. So starting from here, so going to project, and then creating the project, attaching the billing account, link billing account, that's it, right? So after that, we will be using a Cloud Shell. So this is the free feature, we could say. So this gives us a terminal, a Linux instance, so that we don't have to deal with our local environment, right? So whatever we will be doing, so this will be on our Cloud Shell environment. And this is account specific, not like project specific. So whatever the Gmail account we are using, so this will be persistent throughout the Gmail account. right? Okay, so we'll be doing this one step by step, right? So first thing, git clone, and let's see like how the basic app looks like. Okay, so we just clone, and then we'll be doing the init, right? We need to set a Google Cloud project name. So the project name will be GDG AI April 16 for me. Project ID, done. So we need to enable a few of the services like the AI platform or the compute. And after that, we can just start the project by importing some of the Python libraries. So this is like a super simple Python app with no intelligence or whatever, right? It will take a few minutes or maybe like a few seconds. Okay, so while doing that, we can create a new tab as well, and let's see what, okay, it is done. And then this one, and then we are importing the libraries from Python. And then the last step would be just running the app. And we'll see like what are the contents it was there in the app.py as well. So if you are following along, and if you have any problem with the lab, then just ping in the message as well. Okay, so it's done. So we are just starting the app. Okay, so the app is running on port 5000, right? But we have no way to access the app because it is running remotely in the Google Cloud Shell, right? So there is a feature called Web Preview through which we can, so it acts as a like proxy. So whatever is running inside the cloud shell, then that we can directly view it using the proxy. So preview and port 8080 is the default one, but our app is running on port 5000. So just enter 5000 and then see. So this is our simple app. So it does nothing. So whatever I say, it will just reply back. So it has like no intelligence at all, right? So let's go into the next step. So the second thing is we need to add some brain over it. So if we are building a chat app, then it needs to have a brain, right? So let's see how we can add a brain. So the brain would be an AI agent. So what is an agent? So agent, you can see like it interacts with the model, like Gemini, Claude, or whatever model, and then it uses some of the tools and then get us a goal, right? So what we will be doing in the next step is we'll be creating an agent which will use some AI model, and then which will use the tool as well, one of the tool, and then we'll be making our chat app a like super fancy one, right? So we'll be focusing only on the agent for now. So how to build an agent? This is the ADK. So agent development kit. So this is an open source project from Google. And it is like, it makes a building AI agents a lot more simple. So you can go into the documentation as well and see how we can build the app. But for now, let me go into my own document, and if you have been to the same Git repo, so there is a one of one folder in there. So here I have like the step by step for building an agent. So let's do it quickly. So let me go into local. Okay, learn agent, and then I'm creating a UV environment, a virtual environment for Python. So for that I'm using UV. So if you have used like virtual env for Python, maybe UV you might feel like a lot more simple. UV init, and I'll be adding Google ADK library and A2A. A2A is not required because we'll not be dealing with like agent to agent or the remote agent to agent connection. So we can just use Google ADK. And then let's create an agent folder. And ADK create first agent. So let's create a first agent. Okay. So let's see how simply we would create an AI agent. So it is asking for the brain, right? So which AI model we want to choose. So let's choose Gemini 2.5 Flash. And for this, which platform would you want to use? So let's use Google AI, because the reason for choosing Google AI is we don't need to enter like project ID or like car details or whatever. So we could use AI Studio for that, for generating the API keys. So let's go to AI Studio and then create API key. So here is the API key. Okay. So we need to run the agent. This one, and then let's see. So import 8000. So we have the agent ready. So we have our first agent, and we can just interact with tell me about some stars. So we have our like fully functional AI agent ready. So you could see, and behind the scene, so while we created our first agent, so this is the agent file. So this is the like main brain of the agent, right? So the root agent, which is the most essential thing and which is executed for the agent file as a default, and we are specifying the model Gemini 2.5 Flash. So when we are interacting with our ADK agent, so Gemini 2.5 Flash is getting us all of the information, right? So we created this one, but this is not sufficient, right? So if I ask like, what are news today? Let's see, this simple. It doesn't have the information, right? Because it's just using Gemini 2.5 Flash. It doesn't have access to like live feed of the information. So let's add some tools over there so that it could get the live news, right? So for that, so there are the tools. There are lots of tools. So if you go into ADK documentation, ADK tools, so there are lots of tools, but the simpler one we'll be using is Google search, so that when we ask the agent some of the information, then it will use the Google search tools and get us the latest news for today. So for that, it's making it way too simple. Google search for importing, and then we'll be using the tools. So the tools is Google search, right? So just by changing this, so let's restart our app. Okay, and then go into the same web app, new session. What are news today? So tools added a lot more functionality, and we could use like, so okay, so we have like the latest headlines of today, right? So tools gave it a lot more information, a lot more context, and we could customize by this way. So the background or the reason for showing all of this is we'll be using the ADK agent and then the tools also in our lab, in our workshop lab, right? So up to here, we have our beginner app ready. And then, so the next one is creating the agent with Gemini CLI. So what we did is, so locally, if we have to create, we have to like write lots of steps, right? So we might have to remember all of the agent file content and everything like that, but we won't be using this way. So let's do some vibe coding through Gemini CLI, right? So for that, so creating the brain, we're using Gemini 2.5 Flash, let's see. But using that but for creating that, we'll be using Gemini CLI, right? So for the, let's say like vibe coding. So Gemini CLI, you could go into the Gemini CLI documentation. The installation step is super simple, but I guess the Cloud Shell already have the the Gemini CLI installed, right? So when you install Gemini CLI on your local machine as well, so it's this one, Gemini CLI, and then enter the Gemini command and we can interact, right? So let's do that. Okay, let's go back to lab. So just the Gemini. So we'll be going to our root folder and then the Gemini. So why yellow? So this is not working currently. So there are lots of like background works for the configuration files. So we'll be just entering Gemini for now. So here, Gemini. Okay, so we have our Gemini ready, and we could just ask like, what are news today or something like whatever. So this is just interacting with some any kind of AI agent, right? Okay, so let's create a Python code or the character.py file. So just like we created agent.py file by running the adk create command. So instead of agent.py file, so we are asking the Gemini CLI for generating a character.py, because our super simple like chat app, so we want to give a character for this, right? So we want a character.py file, but the code should have the ADK as in definition, right? So the code must have LLM agent, and we'll be using the Google ADK, right? And should also import the logging and the OS library, and we'll be using the root agent as well, and also 2.5 Flash. So we are just writing some instruction for the Gemini CLI to generate the code for the agent. So let's go back in here and let's just paste. Okay, so I want to allow once. My font is like super messed. Okay, so character.py file is created. So let's go back into another terminal. So this is like just switching the lab if you are confused or using Cloud Shell for the first time. So we are inside companion, and if you see character.py, so this is the same similar file the Gemini CLI created. So the instruction is URL friendly. If you see in companion, we can interact with the user and start a conversation, right? So let's try our app once again. So we created up to now, and then so let's run our same app again. Back to the same terminal. Let me cancel the Gemini CLI and then run our app. So this time it has a brain. Let's see, port 5000 is good. Okay. Okay, so it has the information, because earlier when I say hey, it is just replying with hey, right? What are latest 2 news today? And let's see what happens. Okay. Okay. So okay, so the thing is, so it has some intelligence using Gemini 2.5 Flash, but it doesn't have the access to the latest news or the latest things, right? So we made it some kind of brainy, but not too sufficient. So the next step would be adding the tools for this chat app as well, just like we did on our 101 app. So let's go into the next step. So we are enhancing the persona as well, right? So here, so if we check on the character.py file, so there's no instruction, there is no persona, like what is this app doing, what is this character doing, what is the intention, nothing like that, right? So anybody can ask anything, maybe it could respond, but let's give it some persona by adding some instruction as well. So that's our next step. So persona means maybe we could give its name, maybe we could give some kind of the personality, or maybe we could give it some role or expertise and what are the context it should follow, or maybe like if it is if the question is out of context, maybe just don't reply or things like that, right? So we have an example persona. So it is a like super intelligent cat. When it is when someone asks, maybe it is morely focusing on some kind of its own habit or its favorite topics or things like that. So this is like simple example persona. But instead of writing this persona or the instruction, we'll be using the Gemini CLI again. So in the Python file named character.py, find the LLM agent, and inside the assign to the root agent information. So we are giving the task for adding the instruction, right? Okay, so let's just copy and then back in our terminal. Let's stop the app and Gemini. Okay. So it'll ask for the example persona. So let's copy our example persona as well. Okay. So the Gemini CLI will be updating the character.py file by adding all of the external persona for our character. Okay, defining the replacement strategy. Anybody following the lab? Okay. Okay, so the persona, sorry, the instruction parameter. So this is the instruction, right? So we gave it some sort of character as well. So let's restart the app. Okay. So is anybody following the lab all along? Yeah, CLI means the command line interface. Okay, so we are allowing one. So there are the options whether to allow at once or allow everything for this session without asking anything, or maybe we could modify, or maybe just discard the change as well. So I'm doing allow once so that we could see every single step. Okay, so the instruction is updated, and let's run our app once again. And the same thing, the app will be accessible on port 5000. So if I ask, hey, so okay, so the context, like you can see, like I'm Waku and all of the super intelligent cat. So the context it is getting from is our file called character.py file. So if you see character.py file, so we have added the instruction, right? So we have added all of the rules, like you are Waku. So if I ask like who are you, then it will say like Waku. Or if somebody asks some kind of a question, then it will just answer based on these instructions, right? So we gave it some sort of more brain and more context. So let's go into the next step. So up to here we gave it the instruction. We using the instruction file, we gave it some personality. But next, let's give it some more capabilities, right? Extending its capabilities for maybe additional knowledge. So let's give it some search engine capabilities. So just like we did on the 101 app, let's try to integrate the Google search tools for that. So the next step, so if you are following along, I don't think like it will be like super complex. So what are the new things we'll be doing? So we'll be importing the Google search as a tools inside the ADK, right? And using the same Gemini 2.5 Flash, and the tools will be Google search. So let's just copy the whole file. And also interestingly, we could also use the open editor. So we don't have to deal with the terminal at all. So if I open editor, you will see a nice VS Code kind of dashboard. And we could also access all of the files. So if we go in here, our character.py file, so let's replace all of the character file by integrating the Google search as a tools, right? So we could also like run the same command, like running the app from here as well, or maybe going to the terminal again and then restart the app. So I'll restart the app from here. And let's go again to the app. Then the app will have brain of Gemini 2.5 Flash, and then also some additional context through the Google search tools. What are latest news today? Tell me only one. Okay, so you can see like, so it is showing some of the context we gave. So it is chasing all of the sorts of the new mice. So you can see the language. So it is not just replying, hey, this is the news for today, because we have added the instruction and a persona for that. And it got the latest news as well. So it has all the context from the AI model and the tools as well. So what else? So let's do some, make it more smarter, let's say. And we'll be using a new tools or the new thing called MCP server as well. So this will be interesting. So there we'll be learning a lot of things. So let's go into our lab once again. So we have our image in here. So you could see this cat image, but let's try to change the image by using Nano Banana's MCP server, right? So this is like super simple also. So we have a MCP server in here. So if you just do git clone, let me close or maybe use another terminal. Okay, I have my folder already cloned. So if we go into Nano Bananas, and then the MCP server. So this is the Python code for running an MCP server, which interacts with Google Nano Banana for generating the image. And we'll be using Gemini CLI for creating our image also. So let's go back to here and clone and then install all of the required files. And then run our MCP server. So I'm just running up to here so that it won't be pushed into the background. Okay. Okay, so our MCP server is running on port 8000. But how do we create an image, right? So we need to access, we need to have a way for accessing the MCP server. So for that, we'll be using the Gemini CLI again, right? So Gemini CLI will be using an interesting file in this location. So Gemini CLI settings.json. So if our Gemini CLI needs to interact with MCP server, so we'll be giving the MCP server link on the settings.json file. So this is by default on your home directory .gemini folder and then settings.json file, right? So let's do that. So let me copy all of the contents so that it is just doing like not super fancy thing. So if the Gemini CLI settings file exists, then it will just append the MCP server and MCP server link or the URL inside the JSON file. So let me copy all of this. Okay. Now the next step would be just running Gemini. So let's see our Gemini can interact with the MCP server or not. Gemini list. Okay, so we have our image in and Nano Bananas. So these are green so that it could interact with our MCP server, right? So let's try to create an image. So generate a lip sync image with high quality digital something. So let's try to create a new image so that our chat app will have super nice image. Yeah,
Hi, Raju. I think you have a question for you in the chat.
Okay. No. So we are creating an image by using the MCP server only. So the chat will not, it is not associated because our main lab is up to here, right? So the bonus is so that you will be knowing like how to interact with our MCP server by using Gemini CLI, right? So this is, so we cannot change our, with the current logic, we cannot change the image in a live environment. Okay. Okay. Let's see. Okay, so I think like there is the permission error from my account. Let's see. Okay, so while doing that, so what we learned today. So first of all, we started with a super simple app, a Python app. It's nothing to do with it. And then we added an ADK agent to it, right? And then by adding a simple brain through the ADK agent, Gemini 2.5 Flash, so we got to interact with the chat agent, right? And then we added some personality by giving the instruction for the app or for the ADK agent. And then we added new tools, ADK tool called Google Search, so that our chat app could access live news or live information as well. And then for the custom avatar, so we are creating the image as well. So let's see if there is any problem, or let's see. Okay. No, I didn't want to enter the prompt or like change the prompt, so I we'll do no suggest. I think I have some authentication error or something like that. Let me check again if it is created or not. Okay, it's freezing. Okay, I see some of the authentication error in there, probably with the keys in a remote environment. But at least like the gist is we could use our MCP server through Gemini CLI by using the Gemini folder and then the settings suggestion file, so that we could interact with the AI model to generate our image for our app. So that's like the basic gist for now. Okay, so what else? So what next, right? So in this slide, you will get like lots of resources. Out of that, I will suggest the skills.google. So this has lots of labs as well. So if you want to learn how to build agent by using ADK, or maybe like multi-agent by using agent to agent protocol, or you could be interested in making it deployable to Google Cloud Run, or maybe like somewhere else. So you could use lab as well. By going to the link, there are lots of resources over there. So this is a good learning resource. And if you want to learn more about like how to create MCP server and interact with ADK as well, because for now we are using MCP server with Gemini CLI only, but if you want to use MCP and ADK combinedly, then this lab could also be a good one. So yeah, so if there is any problem while following the lab, I guess like nothing should break except for the authentication thing in my environment. But this should be like super simple. And back to the first one. So while activating the billing account, just make sure you are creating the project by using the correct billing account, so that you won't be charged. You won't be charged because we are not using any of the like more tokens, but it still just make sure you are creating project by choosing the correct billing account. So that's it for now. And I guess the GitHub link, so let me reshare it again so that you could also access it in offline. So if you're just starting to build AI agent, maybe the first one, 101, would be a good place to start. So I have some of the projects as well for using Google Search Agent and Sub Agent as well. So just follow the README and then start building agent. And then the next thing could be you could go into the code labs and start doing the actual lab. So and for all of the cases, you could just use the same GCP credit. Let me paste the Google Cloud link. Yeah, I think that would be nice. Yeah, maybe like change some Python logic, or maybe ask Gemini CLI to change the logic for creating a new image based on the chat app, or maybe based on chat interaction. Okay, thank you all for now. If there is any question, let me stop my screen share and we'll deal with that.
Thanks a lot, Raju. That was really amazing. And if you have any question, you can like put it into the chat, or yeah, you can reach out to us with email. We will be love to follow up with that. So thanks a lot for your amazing presentation, and we are really happy to have you today.
Yeah, thank you.
Yeah. So yeah, we will move to our next presenter. Let me share my screen. Yeah. So I will give a brief intro to Michelle. At first, thanks a lot, Michelle, for being here. She's a software engineer with experience in building software applications. Over the past years, she has also built and nurtured developer communities in Nigeria. She is a pioneering GDG Saba co-lead for Asaba, where herself and her teammates build the community from the ground up too. And she also became the first women tech makers ambassador in Asaba. So she pioneer. Sorry, is there anything in the chat? Oh, okay. Sorry about that. And she also pioneer of the women techmaker community in Asaba, which has so far impacted more than 300 youth women. It's amazing. She has extended her drive towards mentorship, tutorship at She Code Africa. She also did one-to-one with Bucci, I would say, where she has tutored and mentored young people on web technologies. She also participated in a Women Developer Academy (WDA) program for SSA, and her goal is to shine more than a light on capabilities and improvements. So that's huge. So virtually, we will give a round of applause for Michelle. Please, Michelle, you have the floor. Go ahead, and I will stop sharing. You can share your screen and take it from there. Thank you. Michelle, are you talking?
Yes, hi. Thank,
Hi. Yeah.
thank you very much, everyone. Um, it's a pleasure to be here. Okay, so I'm just trying to share my screen. It's morning where I am currently. So yes, um, and it's also a new day as well. Okay. So yeah, we'd be doing. I'd like everyone to be hands on. Thank you so much, Raju. I loved your session, and also thank you for going through the cloud credits renewal so that I just like get started already without having to do that. So um so now I'm going to share my screen and then I'll get started. I'll get started with like I'd normally do. I'd just like to like break down a few concepts and the major reason this topic is quite important and why we'll actually need to like delve into it as well. I'd probably just share my whole screen. Okay. So I'd share my whole screen so I don't need to like keep moving. Oh no, pardon me. Okay, great. Yes. So this will let me. All right. So today we'd be looking at memory. This is what we'll be doing today, our code lab. But before we move into the code lab, what we'll be doing today is how to add short-term memory to your AI agents. How to add short-term and long-term memory to your AI agents actually. And then I'll take us to understanding how memory works in agents. Then we'll also get on hands-on with our code lab today. And then would now proceed from there. So I want to believe that everyone has been able to renew their cloud credit through the Try GCP so that we can all follow this session. Okay, so now the major goal of this session is to understand memory, right? All right. So the major goal of this session is to understand memory, and I'll share the link to this session in the group chat shortly. Now, one of the major reasons why memory is so important. Initially, LLMs they do not have memory on their own. Like they are like a I don't even want to say like a notebook, because notebooks can be filled up and they can remain filled up. However, for LLMs it's quite different. They do not have the ability to think on their own, to act on their own, right? They do not have the ability to to do things on their own. So basically, you have to always prompt them. I know that currently where we are in terms of using in terms of LLM memory and in terms of using LLMs to build your applications. If I'm talking about memory, I know some people like, well, I use ChatGPT, I use Gemini, and if I speak with Gemini today or if I speak with Gemini tomorrow, it's able to understand and it's able to know what I'm trying to say. However, this memory for LLM has been sort of like you can easily call it a superficial, it's been superficially applied, right? It's been superficially applied. And because of that, memory is one of the very important concepts when it comes to LLMs. So just give me a second. I just want to quickly jump on it right now. Okay, but before I continue, have we all been able to retrieve our cloud credits? So I'd like this session to be very interactive. So it's not as though I'm just the person building, like working on and building what we're building. I like it to be very, very interactive. Right.
I
Now,
believe everyone got their
okay,
cloud credit, yeah, and they're trying their own as well.
great. Okay, great. So, like I said earlier, normal large language models are able to do things on their own. They can do what you want them to do. For instance, agents, as we all know, they're even becoming more autonomous. They're able to do things on their own. They're able to act the way you want them to act. So if you ask them, oh, how do I do this and how do I do this, how do I travel and how do I get here? However, one of the major issues has been memory. So if you have been following the turbo quant research, you would understand the parts where they talk about the turbo quants and then the polar quants, and then you really understand the real essence of vector compression, right? And the efficiency and just creating more efficient space where memory is saved and how memory can now be stored. Imagine a goldfish, for instance, now, like where you're just like throwing things into. You throw something into it the first time, it doesn't understand. It understands you. The second time you come and you say, "Oh, based off what I threw to you the last time, do you understand? Can you explain this other thing?" And it's totally blank because it's not like human beings, right? LLMs are, of course, the goal is to be able to get them to become like humans, but they are not like human beings in the sense that when you throw something at them, they do not automatically remember those things. You have to act towards ensuring that they remember those things. And over the years, one of the major ways that memory has been there have been major ways that memory has been stored. There are three types of memories, which we have the short-term memory, the mid-term memory, and then we have the long-term memory. Now, short-term memory would have to do with your session and your states. So I would show you that. So in this code lab, we'll be going through the tree. We'd first look through how we're able to get short-term memory. Then we'd also look through how we're able to move from short-term memory to now getting mid-term memory. Mid-term memory will now have to do with catching and storing data in databases as well. Then long-term memory would in this code lab we'll be making use of the ADK long-term memory server to store our long-term memory, so that when you leave, like after a while, you still return, your memory is still there and you are still able to continue your conversation with your LLM. Now, when Raju was talking, I think he mentioned, I'm not sure. Okay, but yes, so basically, let me just use a very quick example. Let me say Gemini now, or ChatGPT, or whichever medium that you have been jumping around on. You'd notice that sometimes if you're using, let's say it's most prominent on people that use, like, say, free plans, they would say, oh, your memory is full, clear your memory, right? They would say your memory is full, clear your memory. Now, this is because currently memory is extremely expensive. It's extremely expensive and it takes a lot of space. But, and that is another reason why, that is another limitation to even getting to the point of AGI, because for you to be able to get to the point where LLMs become extremely powerful, where LLM memory does not decay as often as they would normally do, you have to be able to ensure that memory begins to take lesser and lesser space for the same performance. So, for this particular um chatbot, we'll be building something like a personalized, stateful chat system that just allows you to plan your events and plan your trips. So let's just go there. If you're following me on this code lab, please activate your try GCP, get your coupon, your credits, as Raja has already taken us through already. Now we'll just go through this process. This is a very, very simple code lab, very workable with, something you can just quickly do as you're coming along. Now, the first thing I would do would be, because I've done this quite a number of times, I would need to, I might need to create a new project for it. But for instance, now when you are trying to do it, you don't need to create a new project for it. You can easily just, proceed, because the install that would be making use of just automatically creates a project for you. Do you get? So you won't necessarily have to go through all of that. Now, the first part of this is enabling your billing account, and then the next thing would be to to go to this place, which is the Cloud Shell editor. We used that earlier as well. So you go to the Cloud Shell editor, just click on this link. If you, okay, I said I was going to share this on the, so this is the link to the code lab. Yes, please. This is the link to the code lab. Just click on it and follow me. If you want me to wait for you, can you just say something in the group, so that we don't move and we quickly just hold on for you. I would like everyone to follow. So click on the link and then let's get started. Like I said, the first thing would be setting up your space, enabling your billing account. And then the next thing would be to click on this link, which is the Cloud Shell editor, because we'll be building what we're going to be building on the cloud. Then, if you notice what I did earlier, I authorized my own, I authorized my space, like I accepted and I authorized it, right? Um then the next thing that we'd be doing, for every time that there's a bug in our system or our code base, we would use Gemini to resolve it. Like Gemini, so basically we are able to make use of Gemini here. So it just allows it makes it's able to interact with our cloud editor, like directly interact with our cloud editor, like a code assistant. So whatever issue that we face, we'll just drop it there and then we'll fix it all together, like here on the call. Now, we'll just go through the exact steps in this code lab. The first thing is to click view, click terminal. So if you are following me, just follow these exact steps, right? When you get to this point, you click on view, you click on terminal, which we already have clicked. That's in case you do not have yours opened, your terminal opened. Then the next thing would be that you need to list your authenticated accounts. So we need to verify that our account is authenticated. So this is my authenticated account. Now, if I want to, like I said, this would automatically, by the time we would automatically.
Uh, Hi, Michelle. Just wanted to tell you that the link you provided is not working. Like it gives a 404 error. Could you double check the link, please? Thank you.
Okay, sorry about that. Try this. This. Let me know if this works. Okay, great. Thank you. All right. So I'll just proceed from what I was saying earlier. So just follow through, just like it's a walkthrough process. The first thing you'd need to do, you'd need to check if your account, if you have an authenticated account. Now, if you do not have an authenticated account, it will prompt you so you can log in. However, if you have an authenticated account, like like what I just did now, you see, I have an authenticated account, and I can easily just say, okay, I can easily just set the exact um account I want to use or change the account that I want to use right on the cloud. Now, but like I mentioned, when you clone this Bootstrap project, it automatically creates a project for you. So you don't necessarily have to link your account to a project anymore. I might have to do that, but let's just go through. Yes, because this destination already exists in my application. So from, let me see. Oh, okay, great, great, great. Okay, so let me know how many people have been able to get started with, you've been able to access the G Cloud lists. You've been able to access G Cloud lists and you've gotten to this point, like to the points that I had on my screen. So who has been able to get to this point? Who has also been able to clone? So I just give like 2 seconds for everyone that's just catching up, just in case you're not able, I mean, considering that the link was faulty and all. So we'd quickly proceed. Okay, so I want to believe that everyone now is able to continue with me. Great. Now we'll just proceed. Like I already mentioned earlier, I I sort of like already have a few things set up. So in case you are following, you just need to clone. Like I already have it cloned. So I cannot reclone because this path already exists in my directory. So it's not an empty directory, except if I go to delete it, right? That it won't exist anymore. Now, what I just did here was I just went through, I just listed my projects so I can I can go into this particular directory, which would still all do. Now, I would not do that so that we can all go through that process. Now, the next thing would be that would run this setup basically to going through that particular directory which we have just cloned. So if you notice, the minute you cloned that directory, it automatically created a project for you. So let's just go like this now. It also tries to check if you have a billing account, like active billing account, like not the one that is dormant or something. So in case you try it out, okay, so in case you try it out, and you get an error, just know that you have not linked your billing account properly. Okay. Now the next thing that you need to do would be to set up your project. So it's just basically to just follow the exact thing that has been done already, right? Now, after we have set up our project, we have our project set up, we have everything that we need for this particular project. The next thing that we would need to do would be to enable the required APIs, because we are dealing with Google Cloud. I'm also dealing with Google Cloud Memory, and we're also dealing with basic services. So these are the APIs that would need to enable. So just copy it as it is here, and then you run it on your, like, you'd run it here and proceed, as well as granting this the memory agent. So this memory agent, remember that this is what we cloned initially. This is the project that we cloned. So in case you do not want to use the cloned project, you just want to use, you don't want to use like this starter pack, you want to do something from scratch, you can create a brand new project, but you still have to run a step to just give it access. In this project already, we already have we have a .env file, we have all the files that would normally need to proceed with our with every single thing that we're running today. Now, like I said earlier, there are three types of memory. We have the session and state, sorry. The session and state is the short-term memory, like I mentioned earlier, which we are going to test now. The second stage of memory is the midterm memory. So that has to now do with mostly would now have to do with catching. So for midterm memory, it goes beyond the initial session, right? So for instance, now when you refresh your screen, for session and state, it would, because it only stores it using the session storage ID. So it means that for every time a session is erased, the memory of that large language for that of that agent is also erased. But what we're trying to do, we're trying to see how your agents, whatever you're building, can evolve from just merely using the session and states to now trying to make use of the midterm memory, to now trying to make use of long-term memory. So now what we're trying to do now is to go through our agents, examine our agents, and ensure that everything is okay. Now, we'd get started. Okay, so far, is everybody else following on the call? Are we all able to? Can I just see comments? If you're following this session, can I see comments? I'll just quickly stop sharing so I can see the comments properly. Can I just see comments if you're following? what's where you are, what you've been able to do, which part of the session have you been able to get your cloud credits? Have you been able to list your projects? Are you stuck on any part of it? So can I just see comments if you're following this session, or if you're having some troubles with following? Can you just let me know where you currently are? Anybody? Okay. Okay, great. So I'm just seeing one okay, okay. Talking about okay, okay. All right. Um all right. So we'll just proceed from there. All right. So now the next thing that we're trying to do now is to get into just following, we're still following, we're trying to get into this agents.py. But if you're currently following, you should be able to run this so that you are able to get into this page, agents.py. Right. So in my own, I'm not able to access the agents.py from my end. So like I said, when there is any issue, um I'll just trade in at Gemini, so that Gemini is just able to help me and help you as well. So that when you're building anything, it's very easy for you to just quickly fix issues, right? So I'm trying to access agents.py. Oh, okay, okay, it's in my it's here actually. So I need to go to my O1 session agents. All right, great. So this is my agent.py. Now, in case you are like faced like you're getting stuck at any point, do not panic, do not get confused. Just know that you have Okay, so I'm still trying to access my agent.py. So in case you're following, please, if you follow, okay, okay, so if you're following, right, if you're following and you, so I'm getting stuck here as well, right? Just you can just point me to it. I'm trying to access my agent.py. Okay, great. So my agent.py is opened on my system already. This is agent.py. Now, in case anybody is trying to, like, if you're trying to also navigate this particular step, please let me know if you're having any issues with that. Now, like I said before, because I already have it set up on my system, I might not necessarily have to do every single thing that you'd need to do, but I'll take you through the steps. Now, when you have finally accessed your agent.py, like I finally accessed mine, you need to go through this. You're going to see a first to do, which is called create a root agent. Now, remember that what we're trying to do is to create session and state memory for our agents, because our agent is like a cold goldfish. It doesn't understand anything, so it means that we have to give it the initial memory. And to do that, we'd first create the root agent. Now, this root agent, what it would do is that it's going to be where every other agent as we move, you'd notice that would create sub agents, would create agents for travels, agents for planning, but this particular root agent is like the sub agent for every single thing that would do. And I already have that here, so I don't need to create that anymore. But if you're following me, you would actually need to copy this. You would need to copy this and paste it in this point, at this point where you see to do create a root agent. So when you paste it there, the next thing that you would need to do would be to access your main.py. So you'd need to access your main.py. Okay, so I just throw this at Gemini to help me fix this. I'm not 100% so in case you're able to help me figure out what the issue is, I'm personally not 100% sure, because I've worked on this a number of times, so I'm not sure why I'm not able to access it. Now, for if you're just following me, right, in order to access your main.py, you would need to just simply run this. You'd be able to access your main.py. Now, my main.py is opened. The next thing that you need to do would be that you need to also replace this whole line with this code. Now, in your main.py, there in the whole starter pack, remember what dealing with a starter pack, there are lots of to-dos. And because there are lots of to-dos, we'll just be following the starter pack. We'll just be following all the to-dos as well as the code lab. Now, the next thing that we want to do is to be able to create a runner with in-memory session service. And for us to be able to do that, you need to replace the to-do that you have with a create a runner with in-memory service. So basically just replace it with this. I already have this set up, so it means that I don't need to do that anymore. And then you'd also be able to create a different session tests right inside your main.py by still taking this and replacing it with the to do that has been set there. And then for this particular scenario, right? For like this, for now, we want to test. So if you have been able to get to this point, congratulations and well done. So now we want to test our first implementation of our session memory, which is also the stateful memory, just ensuring that our memory has states for that particular session. Now, what we're trying to test is this. This is our shared session, and this is our stateless session, right? Our shared session and our stateless session. So what we'd now do next would be that in assessing our memory, we'll try out a few scenarios. Basically, what I'm currently doing is just basically running the Python, right? And giving it some scenarios. Now, let's read this together. I just drag this up a bit. So what I want you to take note of is to take note of this step and the step where we would clear our session. Then to take note of the next steps and the step where we would still clear the session. So you can understand how we are able to store memory beyond the session. So in this first scenario, it's a scenario one, which is Tokyo trip, and it's adapt using the adaptive memory. So what I've sent to it, because I already added this prompt, I already added it to the code base. That's why I see I didn't need to type it in this terminal, because already in that root agent that you created, I've added my prompt and everything to the code base. So the first user, hi, I want to plan a 2-day trip to Tokyo. I'm interested in historic sites and sushi. Now, this is the first, immediately I ran the code. This is the first prompt that I ran. And then it's the LLM is able to like give me every single thing that I need, right? And then the next thing, this is also the second scenario where I now ask the LLM about a 2-day trip. It's still able to like give me every single thing, tell me about the trip. But then by the time I clear the session, immediately I cleared now because I ran my scripts. In my script, it allows me to run two initial scenarios and then clears the session. So you can see the final response. I'm sorry, it seems like we haven't discussed. Okay, this is food preferences, rather. Food preferences. Now, what we'll be trying out now would be the multi-agent states. So what we have just been able to do, we've been able to give the agent some level of context. Now, by creating the root agent, by also modifying the memory service, we've been able to give the agent context so that it can now store information. Like, so when you ask it something, it uses the context, because memory, of course, memory is built with context. It's also built with a lot of filters. So what we've been able to do is that we've given it initial context to be able to deal with and to be able to work with, so that by the time we want to extend our agent, want to build a multi-agent state. So we're able to like build, like I said, we'll build like sub-agents so that the LLM can have access to other aspects of our our trip generally. Like can have access to other aspects of our trip. So just go here. So and then the next thing that would be doing would go back to our agents.py. And in our agent.py, you would notice that you have something called a foodie agent as a to-do. What you're going to do in that foodie agent is that you would create you create a foodie agent. Now, remember that our LLM initially said that it didn't have any access to our food preferences, but we want it to have context about food, about trips, about places, about culture. So we're going to create a multi-agent state by creating a foodie agent. So what the agent is just an expert in food critique. It's able to recommend the places for you to go have meals when you travel or when you go somewhere, right? So you just go still the same thing. You copy this, you paste it in your foodie agents to do, and you need to paste it in your foodie agent to do. The next, remember we said we're building a multi-agent state, means we're giving the agents more context, like context from different agents like a multi-agent, so that it has context on how to approach different things. Now the next thing would be creating the transportation agents. I already have it in my own, but you would need to create it. You would be able to see something called the transportation agents to do, and then you need to create this and dump it in, like replace the transportation agents to do with this transportation agents. And the transportation agent, generally what it does is it allows you to be able to navigate um through a place, right? So giving it this destination, it provides you with clear direction, it tells you what to do. So in this instruction, there's something I want you to take note of in our instruction, as well as how every other thing would go through this particular place called destination. So this particular parameter that we have created here called per destination, we'll be making use of it in other agents. So just take note of it. Now, in our going back to our agent.py again, you'll see something called root agents. You just replace it with this. You replace it with root agent. Now, if you notice in this root agents in our agent.py, we have now called our sub agents. Remember, I said we were creating sub agents. Now, our sub agents are now foodie agents and transportation agents, right? Now, copy this and now take it back to where you are, to this, which I already have. I already have my foodie agents. I already have my transportation agent. As you can see it here, this is my transportation agent. I also have my goods agents. Exactly what I just told you to do now. This is exactly the points that you are meant to have gotten to by now. And then the next thing that you would need to do is that the goal is that by the time we start to interact with our agents, it should just be able to take us through the whole flow. Like, oh, he understands that I'm going to Tokyo. He tries to like guide me through the places in Tokyo that I can go to. He tells me the kinds of foods that I can eat. Initially, the only thing I wanted the agent to do at the beginning was just to tell me where Tokyo is, how to get to Tokyo, and that was it. I didn't need him to tell me like directions and places and food and all of those kind of things. But now I've been able to create like sub agents, and also now what I'm doing is I'm giving the agents context, which I'm creating sort of like basically creating stateful management for my agents to be able to interact better with me and to be able to understand what I'm saying. The next thing that we'll do now would be to open the main.py again. So you go to your main.py and then you create a single session for the sequential agents. So we'd run our code again. I already have this set up. So in case you are wondering why I'm not doing the any of the dropping and typing, because I already have all of that set up on my system. So it's running now. We'll just wait to see what it's able to find. Remember that initially when we asked the agent, oh, I already cleared it out, but remember that initially we asked our agent to find us foods in the location that we were in, right? Our agent was not able to respond. But now, because we have been able to create sub agents, which the transportation agent, the foodie agents, now it has given our root agents more context and creating more state and more interaction with our agents. So here I say, find me the best sushi restaurants in Paluto. and then tell me how to get there from the downtown train station. Now, the final response, it says to get to Kampai Sushi from downtown, it follows. Now, remember, this was not available before. It never used to tell me how to get to a particular location, right? Secondly, it comes here and it tells me Kampai Sushi is conveniently suited just one block away from university. So it now what it is making use of, it is making use of the destination in the transportation agent. It's also making use of the foodie agent to first and foremost be able to tell me where I can find the sushi, and also to be able to direct me to where exactly I can find the sushi. Now, this is the reboot. So, like I said earlier, the major issue with short-term memory, is that so far everything that we've been doing, remember, we have been creating context, we've been doing states. So it means that everything is in our code base. Like we've just created like session, we're just using our session ID to store our information. So it means that everything is in our code base. We have context, we have state, and it's beautiful. Our agents can now interact with us. However, every single thing that we've been doing has been in memory, in the sense that if I now say stop, my no mine would probably work because I'd fix all those issues. So now from your end, if you say you want to shut down your system and you return back to your system and you want to continue, and you say, oh, um uh the place I went to yesterday, can you tell me more about it, or something like that, the agent would not remember, because it is still using the in memory, which is the reboot problem. So it's usually called the reboot problem. So the reason it's called the reboot problem is that when you reboot your system, or when you reboot the system you're using, or when you refresh the script, right, every single thing that the your agent knew before, it just doesn't know it anymore. It's still able to do what you want it to do. You still have context and states, but you know you only that context and state is only located in your in memory. But we want it to be available beyond our in memory. We want our agent to be able to act beyond just refreshing our screen. Remember what I explained earlier? Most of our chatbots and chats bots like Gemini, ChatGPT, Claude, they've been able to go past the point of having memory that's just like a goldfish. So you can now interact with the LLM, you can return to the LLM, you can now continue conversing with the LLM. But remember that I also mentioned that because memory is expensive, in fact, the truth is that one of the major things that you pay for. So if you subscribe to to agents, to LLMs, like if you subscribe to models, or what do you call, like if you subscribe to, like, basically, let's say Claude, Gemini, or ChatGPT, guys, it will surprise you. Just something that I just quickly want to share. It will surprise you to know that the major costs that you are paying for is not for the agent to work. One of the major costs of that is being covered is how that agent stores its memory. Like basically how the agent vectors are saved, if they are using the vector DB or if they're using the graph DB, right? How these vectors are saved, if they are taking up too much space. So that eventually, the goal is that eventually LLMs are able to be accessed on phones, accessed on like systems without enough memory, systems that do not even need a lot of data, like data or internet connection, to use them. So now we want to move past that in memory stage to now using something called the in memory session service for database session service. Now remember that we are using ADK, we're building on top of ADK. So thankfully, we have the in memory session service that has been built already. So ADK basically allows us to build agents on our own. So in case you're trying to say, oh, I want to even try to like build a brand new agent, just build an agent that I can use somewhere at work. ADK is a very good place to get started with. It's very hands-on and it's very easy. No code, you just really jump on it. Now it has something that is called the in-memory session service, right? It also has something that's called the database session service. Now, because we have been using the in-memory session service all the while, if we refresh our screen, or if you currently refresh your screen and try to have conversations with your agent again, it would not remember everything that you told him. He knows that, oh, my work is to create travels. You've given it context already, right? He knows that his work is to create travels. He knows that his work is to tell you where to go, is to give you direction and tell you the food preferences and where to get them. But it doesn't remember to continue a conversation because, like I said, unlike human beings that are able to generate, like, easily, just remember that the goal of building convolution neural networks in general is to imitate the human brain and to imitate how human beings think and act. So now we want this information to be persistent. So for this information to become persistent, we have to use this database session service. So that's what that would now brings us down to using databases to store data. I just want to also just jump on something quickly before I continue. Um, the ways storing data in your database, right? It's not as though all the data or all the information is thrown there to be too it to take like to be too much. So what really happens is that a summary of the information that has been thrown, like a summary of the information and the conversations that have been had, is what is being stored and what is being retrieved. So now here we now have to do with the retrieval, usage, retrieval and usage. Unlike before, you just have conversations. Now you have to retrieve the information. You have to first store the information using the database session service that's already been written and created. So we don't need to create that anymore. And then the next thing we need to do, so now in our editor, we're going to run this, which I've just done. And then in this file, you would see something called configuration for persistent session. So I already have it set up, like I said. But you that is like following me in this code lab, just copy this, still copy this. Go look for this to do configuration for persistent sessions, and then you paste it there. So if you notice now in this particular, what you're pasting the sessions directory, you're pasting the session DB file, you're pasting the session URL. So this is the DB file that we're currently using. We're building on the cloud and we're using an existing GitHub SATA project. So this is the current, the exact DB file that we're going to be using. Remember I said that we're now using from in memory to database memory. And then the session URL, which would be this. You don't need all of this, like, as in, you just need to copy this and paste it where you are. And then in that same main.py, you would notice that you would see another to do called retrieve the previous session manually. So when you retrieve for us to be able to, remember I explained earlier, for in-memory, you don't need anything like retrieval. It's just there, like it's just there. You don't need to retrieve anything. There's nothing to retrieve literally. You're just basically providing context and set and states. You're just ensuring that your LLM is stateful. Now, I'll just take this. I already have it set up. Same here. Manually inject the context to the query. So I'll still replace this with what we currently have, and then surviving the reboots. So after all of that, now what I want to do is that I want to reboot my LLM and test it with my current database memory service that I've taken from that I've been able to take from the ADK package to use in my own application. So in this time when we run this, we'll look for something called resumed existing session. So if you see something on in your own terminal called resumed existing session, it means that you're continuing from where you previously stopped. You're not starting afresh. But if you don't see resumed existing session, then it means that you probably have not added the code that I sent to you. You probably have not created your database yet, or you probably have not linked your database. So it ensures that user conversations survive several restarts and enables long-term history analysis. So I just run this as well. So if you now for my own now look at if you please look at this. I have resumed existing session. Now it's and remember what we called it, my persistent trip. Let me just quickly show it to you. Let me just quickly show that to you. Remember, we're using the trip planner database. The reason it is able to resume previous session, even after I like used this to like clear up my space and the session and also sort of like restart the session, is because I now use the DB session service, right? I now use the DB session service, and so now it's able to like resume existing session, and the existing my previous session was my persistent trip, and so here it just goes hi again, like we've met before, literally, right? Because now we're using the retrieval method. We're no longer using just the initial stateful in memory method. We're now using the retrieval method. And he says that great to hear you are planning a trip to Tokyo, and I've noted your love for ramen and that you are a vegetarian. This is everything that we discussed previously. We didn't discuss it now. I didn't tell it anything about me going to Tokyo or being a vegetarian. You can see, like, this is a brand new session, but it totally remembers every single thing that we learned, that we talked about initially, and then it's we just like just oh okay, I'm having slides. I'm not sure. I think there's a slight error here. I just try to fix that. Okay. Oh, okay. So it's saying that this session already exists. Um, and it's saying this particular session that I'm trying to run already exists, right? But of course, you would not have that error because you've not done that previously. Now, the next thing, I'll just try to rush up. I think that my time is almost up, or I think it's almost up if I'm not mistaken. The next thing, the final, we'll just rush through the final steps. Now, the spy callbacks. Now, the spy callbacks, how in that's like how it's called, right? Sometimes you might need to like update your memory automatically based on what the agent does, not just what it says. So you need something like a spy, similar to a spy that can watch your agents and take notes. So this is basically how the callback, the spy in ADK is built. So you have your agent, you have the before the agent callback, you have the after the agent callback, the model, the tools, and all of those kind of things, which I'm not going to bore anyone with right now. And then the first thing would be to go into your agent.py, still replace the implement callback logic. So you need a callback logic, something that allows your callback function to be able to spy on the agent and add more notes to it and say, oh yeah, you can add this, you can add that, right, to the agent. So you just copy this and replace it with the implement callback logic. And then the next thing that you need to do would be to look for this to do called add callback to the root agent. Still, remember that we created a root agent in our agent.py earlier. So you would replace it with this line because this is the callback that we have just created. So you'd add it to your root agent, so it is readable and usable. Because if you do not add it to your root agent, it can't be used. Because I mean, it's just a function that's just lying there without any use. But we have to add it to our root agent so that we can be able to use it. And then in our terminal, we can now run this. If the error, so remember what I said, if you're working on yours and you get stuck at any point, just use your Gemini by the side. Like, it's so easy, and it has context to what you're doing. So when you paste your code, it just reads through and understands exactly what you're doing and is able to fix it for you. Now, because we made use of the spy callback, so the master planner is ready, and you can just read through this. Plan an afternoon activity for me, because I've said it should plan an afternoon activity for me. It's able to plan a transfer to museum expert, and then it's able to help me to come up with the Kyoto National Museum as the place where it probably thinks. Remember, I didn't have to say I'm in Tokyo. I need this. I didn't have these food preferences. I am a vegetarian, or all of those kind of things. I just basically just had to like continue the conversation from where the initial conversation ended, and now just quickly rush up. And I'm not sure how many minutes I have left, but I'm very sure that it's almost over. I'll just quickly explain the last few terms, which is the tools.py. Now, the tools.py is where you can define the kind of tools that your agents can use. So let's say that now the agents currently, let's say you say, tell me about sushi. In your tools.py, we can tell it to do many other things. So I can tell it that, oh, if you don't know anything about sushi, go through google.com. If you don't know anything about sushi, right, you can save user preferences. So it's in the tools.py. The tools, literally, just imagine having like a spanner, a screwdriver, a welch. Just imagine tools that you'd normally use in your houses, right? That's exactly how LLM tools are. They're like enablers. They're like enablers, literally tools that allow the LLMs to act or to carry out some particular task. Now, it is one thing to prompt the LLM to act in a certain way. I can prompt the LLM, save the user task. But I'm just prompting the LLM, but I've not given it's just like saying, go and trim the flowers. But I've not given the LLM the tools that he or she, like the human being, or however, the tools that he or she needs to trim the flowers. So that's what the tools are. Just imagine it like that. That's what the tools are. And so in this first tool, what we want to create is the save user preferences. So we want the LLM to be able to save every single preference of the user, like every single thing that the user is passing. So we still take this, and then we place the whole line for, we call user preferences tools, so that for every user preference that is stored, we have another tool that is able to recall it. And then we can also go through this, just go again into our main.py, and then we can run the script. I'll just quickly rush up on this and run the script. So you can see, okay, just quickly, so you can see what it says here. I've saved all your allergies. So even if I come back next tomorrow or any other day and I'm like, I want to eat, I'm so hungry, I don't know what to eat, it will never recommend a meal that has peanuts to me, because it knows that I am allergic to peanuts. Now that is what our tool has been able to do. It has been able to help the LLM, our agents, sorry, to adequately store the user preferences and allergies. And when I return, what allows the agent to be able to act properly, like do not have, it doesn't hallucinate. And it's not only based off the prompt that I've given it, it's because I created another tool that allows it to recall the user preference. So now the last part of this, which is the brain, the multimodal memory. the multimodal memory, basically, it just allows us to this is like the huge part of everything that we've been doing since. It's called the memory bank. And so basically what's the humans, I always use the human experience, because the goal is to get to a point where um agents are able to act like human beings, like literally act like human beings, without so much, like the way ChatGPT says clear your memory. The goal is that we're able to get to a point where all those things are not as necessary as they are, because memory takes begins to take lesser space and becomes even more efficient, and the performance remains same or even better. Right? So humans remain more than remember more than text. So humans can remember videos, pictures, and voices, but currently, what we have built, our LLM only understands the text that we have given it. So, in this our Vertex AI memory bank, what we want to do is to allow our agents to handle multimodal memory. So, we want it to be able to take in videos, to be able to take in images, to be able to take in audio and understand it. Currently, it only understands images. So, we'll just update the memory bank, and then we'd proceed, and we'll also update the memory bank customization. So you'd also update the create session service and memory service with this. So this is what we are creating, our session service with Vertex AI session service, which is already existing. So we are not creating the Vertex AI session service. Remember, it's already existing in the ADK package we're using. The Vertex AI memory bank, we're not creating that as well, because it's already existent. And then would replace everything about our memory from session with our await memory service. And then the last thing would be for us to try to retrieve it. Okay, it's creating the agent engine. So as it does that, I just because I'm trying to rush to end this session. As it does that, I'll just go to the final. So it's this using the Vertex AI memory bank allows our agent to become multimodal. So it is able to not only read text, but also read images and also read videos. Now, every single thing that we've done today, like we've done, we moved from in memory. We moved from in. So if you do that, you get a badge. So if you complete this code lab, or if you joined me in running this code lab, you would have gotten a badge. We ran from session agents using short-term memory. We also tried to make use of the multi-agents. Remember when we created sub-agents, like a shared team memory? And then we now went towards creating persistent agents using the database service that is found in the ADK package. And then we created stateful agents. We also created profile agents. And the final thing was we created a multimodal agent that allows our LLM to understand, our agent, sorry, to be able to store images, videos, text, and audio as well. So, lastly, yes, this is the last part of everything that we're doing. Now, I'll just read through this last part. Now, you see, now it's able to even say, oh, give me the audio, give me your video, give me your picture. I'm able to understand it. I'm able to store it, and I'm able to make use of it. And, oh, someone said she got permission denied. Yes, great that you opened it manually. You can still use the link after that to open it, right? So I'll stop sharing now. I'll stop sharing my screen. Um, yes, and I'll just wrap up. Basically, the goal of this session that we've just had is to basically allow us to see that agents are not they don't have these things, they don't have anything on their own. Like they're not intelligent on their own. They don't remember on their own. They don't think on their own. We as builders that we have to like act on them. We have to act on them to make them to act in certain ways. And like I said, one of the major issues in building agents in this current day, memory is a very big issue, right? What we have just done now is to use ADK's database service memory for for persistent memory, but it goes beyond that. So if you begin to like dig deeper into the whole idea of memory, you understand that an agent being able to understand, to first and foremost understand, oh, okay, and yeah, I think I'm done. And to remember is one of the most important things in building an agent. Um, I'm not sure. Okay.
Oshvi, you are unmuted.
Oh, hello.
Yeah, I think there was a lot of noise.
Oh, okay. Thank you.
Am I
Thank you.
unmuted? Hello? Hello?
Yeah, you are unmuted. Yeah.
Oh, okay. Sorry about that. Yeah.
All right. So, like I was saying, the goal of working with memory and building like a system that moves from being like a goldfish to becoming a memory bank is so that we are able to understand that LLMs on their own, they do not act on their own, right? And as we are builders, we're not just consumers of these agents, we are also builders of them. It is important that we understand how these agents work. It's important that we know that memories agents work with a retrieval mechanism, that they retrieve the information and then they also call back, recall the information that they retrieved, that they also use a multimodal logic to be able to understand images, videos, audios, and whatever it is that you pass to them. So it means that from this point, as builders that we are, we can also extend our knowledge to trying to make memory more efficient. By making memory more efficient, we'll get past the cost of memory of sorry of agents. So if you're paying for Claude, I think I heard that Claude is currently like $13 or so per month. Then you have Gemini, you have ChatGPT. Gemini, if you're on a pro plan, so it means you're not paying. But if you're not on a pro plan, you might be paying something like £13 as well, or £19 if you're using the other pro plan, right? But if we are able to get memory to a point where it becomes more efficient, it means that the cost of LLMs will drop by more than two. It will drop by more than two. So I'm just hoping that someone here is beginning to pick some interest. I've been working on memory for a few months now, and it's something that I'm still like doing some research on myself and a few others, doing like some research on trying to find the best databases that are most efficient for compressing memory, and also trying to find the best, like trying to see if would make use of vector graph or would just stick with using like a hybrid tool, right, to ensure that memory stays and is persistent enough, and you don't have to keep clearing your cache or clearing your memory service or your memory server all the time. All right, thank you so much, guys. Thank you very much for having me. I hope you picked one or two things from this session. Thank you.
Thanks a lot, Michelle. Can you hear me?
Yes.
Yes, we can
Yeah.
hear you.
Yeah. Yeah. Thanks a lot, Michelle, for joining this session. And we really enjoyed that. And now I know we are done with our time. It's 7:02 now. So if we want to do some networking, we can put our LinkedIn IDs here. So maybe we can get connected afterwards. And thanks everyone for joining. Thanks Naz and Tree for co-organizing this event with me. Yeah, that's
Yeah,
all
thank
from my
you.
side. Yeah.
Yeah, thank you. So the event, after the event will be shared in your YouTube channel. The whole session has been recorded. Raju has already shared his slides with us. Michelle, if you want to, you can also share with us, and we will send an email with those resources to all the attendees, and we will also share the link of the cloud credits who have joined today. Thank you.
Thanks a lot. Bye bye, guys. Take care. Have a good night.
Bye.
Bye.